Good morning, everyone. My name is Devarshit of CSC B section. This is BWA. My topic is Kirchhoff's current law. Kirchhoff's current law. The algebraic sum of all currents entering an node is a circuit equals 0. An expression of conversion of charge. Kirchhoff's voltage law. The algebraic sum of all voltages around any loop in a circuit equals 0. As a result of conversion of energy. Example, power absorption by a resistor. P equal to VI equal to IR into I equal to IR square, I square R. P equal to VI equal to V into V by R equal to V square by R. Note that P greater than 0 always for a resistor. Example, calculate the voltage Vg and current Ia determines the power dissipated by 80 ohms resistor. Lamped element circuit modeling. Model equal to representing of a real system which simplifies analysis. In circuit analysis, important characteristics are grouped together in lumps. Separate circuit elements connected by perfect conductor wires. An electrical system can be modeled by an electric circuit combination of paths, each containing one or more circuit elements. If the dimensions of the current are small compared with the wavelength of an electromagnetic wave in infinity, that is wavelength lambda equal to C by F less than equal to physical dimension of system, where C is velocity of EM waves and F is frequency of waves. For example, at 60 Hz, the power line frequency in US lambda equal to 3 into 10 to the power 8 meter per second by 61 per second equal to 50 into 10 to the power 6, that is equal to 3000 miles. So we can do lumped elements circuit modeling of ordinary circuit at 60 Hz. Construction of a circuit model. The electrical behavior of each physical component is primary interest. We need to account for undesired as well as desired electric effects. Simplifying assumptions should be made wherever reasonable. Terminology, nodes and branches. Node, a point where two or more circuits current elements are connected, is called a node. Branch, a path that connects two nodes is called a branch. Here are some examples of branch. This is a single branch where it is connected to two nodes, and this is also an example but not a single branch. It has three nodes connected to a single node. This is an example of node. The black dot in the middle is called node. Nation node and branch. Voltages. Use one node as reference. The common or node, label it with a symbol. The voltage drop from node X to the reference node is called node voltage Vx. The voltage across the circuit element is defined as the difference between the node voltage at its terminals. Example, reference node. Here, the black dots are the nodes and the lines are the branches. Using Kirchhoff's current law, KCL, consider a node connecting several branches. This node, black dot, has 4 branches connected to it. Here, I1 is coming towards it, I2 is coming towards it, and I3 and I4 are going away from it. Using different directions to determine where current are entering or leaving the node with no concern about the actual current location or direction. Alternative formulations of Kirchhoff's current law. Charge stored in node is 0. Formula 1. Sum of currents entering node equal to sum of currents leaving node. Formulation 2. Algebraic sum of currents entering node equal to 0. Currents leaving it are including with a minus sign. Formulation 3. Algebraic sum of currents leaving node equal to 0. Currents entering are included with minus sign. A major implication of KCL. KCL tells us that all the elements in a single branch carry the same current. We say these elements are connected in series. Current entering nodes equal to current leaving nodes. Here you can see I1 is connected to I node with a single node. That is, I1 is moving towards I2 and I2 is moving away from I1. And the dot connects the both of the branches. So it is current entering node equal to current leaving I1 equal to I2. KCL example. Currents entering the node, currents leaving the node. Generalization of KCL. The sum of currents entering or leaving a closed surface is 0. Circuit branches can be inside this surface, that is, the surface can enclosure more than one node. I1 and I2 are coming towards the node and I3 and I4 are leaving. This could be a big chunk of circuit, example, a black box. Generalized KCL examples. Generalized KCL examples. The 50 amp this big chunk of circuit, example, a black box. Generalization of KCL examples. 50 mA is the black dot that gets the current and I is the amount of current received. Here in this diagram we can see 50 ohm lambda A and 2 lambda A are the current received towards the node. Using Kirchhoff's voltage law, consider a branch which forms part of loop. Use reference polarities to determine whether a voltage is dropped with no concern about the actual voltage polarities. Voltage rise. Negative drop is when it moves away from the node, and positive drop is when it comes towards the node. Formulations of Kirchhoff's voltage law. Sum of voltage drops around the loop is equal to sum of voltage rise around the loop. Formulation 2. Algebraic sum of voltage drops around loop equal to 0. Voltage rises are included with a minus sign. Algebraic sum of voltage rise around the loop equal to 0. Voltage drops are included with a minus sign. conversion of energy. Handy trick. Look at the first sign you encounter on each element when tracing the loop. A major impulsion of KVL. KVL tells us that any set of elements that are connected at both ends carry the same voltage. We say these elements are connected in parallel. VA and VB are connected parallelly in the diagram. Applying KVL in the clockwise direction, starting at the top, VB minus VA equal to 0, VB equal to VA. 3 closed paths. In this diagram, you can see there are 3 closed paths. One is AB with voltage 2, and V3 is the voltage 3 between B and C with second closed path, and 3 is rotation. An undenying assumption of KVL. No time varying magnetic flux through the loop, otherwise there would be an induced voltage. Faraday's law. Note: anechoics are designed to pick up electromagnetic waves. Regular currents often do so undesirably. Avoid these loops. We do deal with anechoics include a voltage source as the current representation of the voltage induced or noise. Use a lumped current model rather than a disturbed wave model. Consider a circuit with multiple resistors connected in series. Find their equivalent resistance. KVL tells us the same current flows through every resistor. Equivalent resistance of resistors in series is the sum of the individual resistance. Voltage divider. I equal to VSS by R1 plus R2 plus R3 plus R4. When can the voltage divider formula be used? If nothing else is connected to the nodes, it is used because R5 removes condition of resistors in series. In the diagram, you can see in first diagram, there is only 4 nodes and a single node connected to voltage. So that node into the voltage is equal to V2 equal to R2 by R1 plus R2 plus R3 plus R4 into VSS. And here V2 is not equal to R2 by R1 plus R2 plus R3 plus R4 into VSS because R5 is present in the resistors in the series. Consider a circuit with 2 resistors connected in parallel. Find their equivalent resistance. KVL tells us that the same voltage is dropped across each resistor. Vx equal to I1 R1 equal to I2 R2. General formula for parallel resistors. What single resistors are equivalent is equivalent to 3 resistors in parallel. Equivalent conductance of resistors in parallel is the sum. Potential. Here you can see the potential has different diagrams in A, B, C, D, E, F. They have different flow of systems. This is resistance or battery circuit. Current divider. Vx equal to I1 R1 equal to ISS R equivalent. Generalized current divider formula. Consider a circuit divider current with less than 2 resistors in parallel. Checklist of terms introduced. Charge, current, voltage, resistance, conductance, energy, power. Coulomb, ampere, volt, ohm, Siemens, joule, watt, Kirchhoff's current law, voltage law, Ohm's law, series connection, parallel connection, DC, AC, independent and dependent ideal voltage, and current sources. Coulomb is C, ampere is A, volt is V, ohms is omega, S is MHO, joule is J, watt is W, KCL Kirchhoff's current law is KCL, Kirchhoff's voltage law is KVL, DC is strategy, AC is time varying. Thank you.